Welcome everybody, CSCI26 Discrete Math, the most discrete of all mathematics. Today we're going to be talking about the syllabus, getting on Unix, what is discrete math, and our first discrete math problem, modulus. The course breakdown is 20% daily quizzes. A daily quiz takes place after lecture, due at the start of the next lecture. And daily is Tuesdays and Thursdays, so basically you're going to get 2 quizzes a week, each quiz after a lecture. And lectures will be recorded, uploaded onto YouTube, and you can watch them at your leisure. Once you start the quiz, though, you're probably only have 5 or 10 minutes, so don't expect to be able to fast forward around and find things you're missing. There will be 30% of your grade is going to be due to programming assignments because this class is half programming and half math. So a programming assignment will be in C++. You will need to know the standard library pretty well, especially the containers in the standard library. Unordered map, vector, and maybe set. The unordered map is hash tables, set is binary search trees. Math assignments will be a combination of textbook readings on zybooks, which we'll go into a little bit, and worksheets, quizzes, that kinds of things. And 20% will be competency exams. Competency exams are a replacement for midterms and finals. Rather than having a midterm and final, after we finish a topic like modulus or whatever, you'll be given a competency exam, 4-question usually test. If you get 3 out of 4 right, you get 100%. Congratulations, you've passed it. If not, you can retake it. And if you fail the retake, then you can retake it again, but you have to go into the tutorial center first. The tutorial center is available both in person and online. And once you go over modulus or whatever topic with the tutor, they will give you a password, and then you can take it a 3rd time, and if you fail it again, you can take it a 4th time. And after that, I'm tired of rewriting the test over and over again, and you're done. But basically, the highest score you get across all 4 of the tests, if it comes to that, will be your test score. If you pass it the first time, congratulations, 100%. You don't have to take the later ones. You don't. You're just wasting your time if you do that. Okay. So every Tuesday and Thursday, class will be from 10 a.m. to 1 p.m. on Tuesdays and 10 a.m. to noon on Thursdays, with a 10-minute break, 10-minute break every hour. If I don't give you a break, ask for one, and I will give you a break. Once I start going, I just start going, and just remind me on Discord. By the way, all the chat will be live on Discord. Streaming will be live on Discord. Highly recommend you guys be on Discord during class. Attendance is mandatory. That said, the attendance will be taken using the daily quizzes. So the daily quizzes are how you show that you were here online. And if you don't take them, you will get dropped from the class. So it's really important that you take the daily quizzes. I hope everyone heard that. They're all asking Mr. Bell questions on Discord right now, which is fine, but please understand that if you don't take the daily quiz, you won't be here on the first day of class, and you will be dropped. So really make sure you do the first one. And after that, make sure you do them as well, because if you miss a cumulative 4 quizzes, then you're dropped also. So even if you get a 0 on it, it's fine. Just make sure you do them, okay? And they're due at the start of class. So, can we Hello World our first quiz? Nah, it'll probably be on modulus or something like that. Yeah. Yeah, everything will be posted on YouTube, and you can review them at your leisure. All right, so X credit also is available at semi-regular opportunities. We might do peer review coming up in a week or 2. I like doing this with students, where we get submissions to a journal, or a conference rather, and we go through the papers together and rate them. Can you retake quizzes? Nope. Programming assignments, math assignments, quizzes cannot be retaken. That said, each daily quiz is only a couple points, so and they're not really designed as gotchas. If it bothers you, that's what the X credit's for. If you're not gonna, if it bothers you to not have 100%, just do some of the X credit. It's good for you anyway. Okay, so that said, there is one opportunity for programming assignments, which is called Last Chance. So once during the semester, you can submit a programming assignment a week late. Okay, and it will be manually regraded by me. In order to activate Last Chance, you must take your program into the tutorial center, go over your program with the tutor. The tutor will go through it line by line, looking for bugs, offering suggestions on variable names and indentation or whatever. And if you do that, the tutor will message me on Discord saying so-and-so did a last chance. And once during the semester, you can turn in a programming assignment up to a week late. And then I manually regrade it myself. Okay? So I understand life happens sometimes. And that's not to say, like, if you come down with COVID or, you know, last semester a student had their garage burned down of all things. You know, like, yeah, I'm a really reasonable guy. If something happens, just message me. I'm pretty nice. You know, just tell me. My rule for late stuff is, you know, if something like that happens, just tell me before the deadline. Okay? And I'm usually pretty easy to work with on these sorts of things. Will the debugging be specific in this course? We're not doing debugging in particular in this class, but you should not have any warnings in your code. That's for sure. Will there be workshops? Yeah, there will be X credit workshops. I don't know what the topics will be yet, but every semester we do X credit workshops on different topics. Maybe I don't know. I'll have to talk to the ACM. The ACM is the Computer Science Club. I'll talk to them and see what kind of ideas people have for workshops right now. Okay, so you will need to do zybooks. Let me fire up Canvas. And Canvas... Colleague is down. Yeah, cool. All right. So Canvas is here. And this is your central headquarters for the class. The module section, specifically on Canvas, is your go-to place for this class. You should be checking it every day, where every day is like every Tuesday and Thursday, or, you know, something like that. Every assignment will be posted on Canvas. Every quiz will be posted on Canvas. Every lecture URL will be on Canvas. Discord is used for talking to me and to each other. Discord is open 24/7 for help. If you need help with a homework assignment, then go on to the Help Center and ask questions. The only thing we ask is you don't paste large blocks of code, because plagiarism, you know. So, but you can be like, hey, I don't know how to make a hash table, or, you know, whatever. And then people will help you. We have experienced students watching. We have tutors. We have me. We have alumni, and everyone really likes to help out. We have a really good community here at Clovis Community College, where experienced students kind of give back to the newer students and help them out with their stuff. And now that you guys are third semester, maybe you guys can help out with the CSCI40 students, right? And if you want to help them out on the Help Center, like if they have trouble, you know, I don't know, making a variable or something, feel free to help them out. And it's just a really nice culture we've developed over the years, where when we're in person, like usually the first day of CSCI40, we would have like 7 alumni just sitting on the edges of the computer lab, and when people are like all trying to log in, like the alumni just scatter through the room, walking around, helping people, showing them how to log in, write hello world, you know, that kind of stuff. So, is Hazelton here? Yeah, Hazelton's an alumni and a cool guy as well. Although technically he's still taking game development with me, so mostly an alumni. He's finished the program. So, the module section has a link for zybooks. This is your textbook. In fact, we can call it zybooks textbook right here. And if you click on it, it will take you to the zybooks website. If you've never used zybooks before, it is an online textbook, and it's integrated with Canvas. So when you do the reading each week or every other week, it kind of depends again on our pacing, it automatically reports what you've read back to Canvas. And so I don't need to like do anything like too extreme. Basically, I can create an assignment like this where I said, all right, read these sections here. And as you read these sections, you earn points for reading the textbook. And it feeds right into Canvas. And so it's It's all automatic. Okay, so this is what zybooks looks like. And it's got questions. Does 7 divide 56? Yep, it sure does, because the remainder is 0. 7 times 18 plus 14 times 7 equals 364. Does 7 divide 364? Sure, because 14 is a multiple of 7 as well. Does 8 divide 99? Let's say yes. Oh, I got it wrong. Okay, if you get it wrong, you can change your answer. Okay, so again, it's pretty low stakes. Like, again, what I care about is you guys learning the material. And so if you get a question wrong on zybooks, you read why you got it wrong and then fix it. Okay, and some students then take that as permission to just kind of click on everything, you know, and just be like, all right, I'm just going to click on things till I get it right, you know. And if you do that, you're gonna you're not going to learn, right? You're harming your own education if you just kind of do that. Also, some of the things are open response like this. So what is 17? How many times is 6 divided into 17?
2 times.
With a remainder of?
5.
Congratulations, girl. You're ready for college. All right. How many times is 5 divided into 23?
4 times the remainder of 3.
Remainder of 3. Oh, it's not mod, it's div. 4. There we go. All right.
What do you mean?
5 divides into 23 4 times. This one was mod. Mod is remainder. This one is divide. Negative 10 modulus 5. How many times is 5 divided into negative 10? Do you know negative numbers? You don't?
2 times.
2 times, yeah, negative 2 is technically the answer. Oh, no, it's mod. Sorry. Thank you. Remainder of 0. Thank you. Now, how many times does 6 divide into negative 13? 3 times the remainder of 5. Yes, good. zybooks has negative modulus, correct. Negative modulus, by the way, is something that Windows Calculator traditionally got wrong. Google would get wrong when you Google it. Google has a modulus calculator. This is something that a lot of places get wrong, but zybooks has it correct. Okay, because 6 times negative 3 is negative 18. And then 5 higher than that is negative 13. So the remainder is 5. Okay, so anyhow, so that's zybooks. It's got pictures and it's got like animations and stuff like this. And you have to buy it. And I apologize, you have to buy it, but it's worth it. Every year I had students evaluating different options for textbooks, and zybooks won. Is what it amounts to.
Why do you have to buy Why do you have to buy the animation on the text?
You don't buy the animation. You buy the whole textbook here. So.
Why do? Oh, it's a textbook.
This is the textbook. It's an online textbook. So your reading, which will be due next Tuesday, is going to be the first 5 sections of chapter 1. Okay. So you're going to read these guys right here. Okay. So yeah, Hazleton, I did get rid of AT&T. I don't know if I told you that, but I do have Comcast now. My internet is now 15 times faster. So.
Are you still teaching the class where you play Custom Team Fortress?
Yeah, that'll be later in the afternoon. So yeah, AT&T's top tier internet is 15 times slower and $20 more expensive a month than Comcast's gigabit Ethernet. So, yeah, I did have to reorganize my whole office over the summer, but it's worth it. I got a sit-stand desk now, and everything's kind of nice and organized. I kind of like that. So, thank you, Ada.
It does feel like we're getting shorter.
Okay, get out of here. Setup tour. Yeah, sure. I got over here bookshelf. I got my UQA. Got my AC back here. I got another bookshelf with like different computer science textbooks on it, so I can just kind of reach over and all of my commonly used books for classes are like within arm's reach now, so it's actually pretty convenient. So it's out of focus now. Okay, there we go. Okay, so all right, so zybooks, you got to buy it. The link is off of here, and this is the whole textbook. So this is not actually your assignment. That's just a link to the whole textbook. In order to make an assignment, it works something like this. Zybooks week 1. Click here. And so what you're going to see is on the modules, you will see Zybooks week 1 appear. And what was it, 53 points total for the reading. This will be in math homework. And this will be on zybooks. This is how it integrates. If you guys are curious, I'm kind of showing you how this works, and it's going to be due next Tuesday at 10 a.m. and that is a hard deadline. You cannot turn it in late. Save and publish. Cannot be before. Oh, did I not click on that? So publish. And then what I do is I see a Canvas and zybooks linked together. I click on that, click on link to week 1, and there we go. So now when you click on that link, it takes you to the assignment. So don't do the assignments using the whole textbook. It might work, but basically you should click on it through here. And then as you do the thing, when you get to the bottom of every page, there's like a submit button. Make sure you click the submit button, and it will submit your score to us. I believe there's an option to do zybooks without paying for it, but it won't submit your score. So don't think that you can get away with not paying, because they want their cash. I'm about to hit my head on the ceiling fan. Yeah, it's not too bad. Not too bad. Okay, so yeah, so as we go along, the module section is organized by week, and so you can see these are not published. So as the weeks go on, I publish each week, and all of your lectures, all of your quizzes, all of your programming assignments will all be on the module section. This is the most important thing for you all to check. Okay, any questions about the overall structure of the class? You're going to be doing some programming, you're going to be doing some math, you're going to be doing some textbook reading, you're going to be doing some competency exams, taking a quiz every day. You guys cool? You understand the flow of the class? Cool. Right. Should be fun. And like I said, if the coronavirus situation gets better, we will go back in person. But even if we go back in person, it will be streamed online so that people who don't want to go back in person can still participate in the class. So it will always be online. The question is whether or not there is going to be an in-person option. So, all right, see you, Hazel. So that's the situation. You know, I did want it to be in person, but it's just not safe right now. Okay, so let's get everybody on the Unix server. So there is a program called Putty. If you use Mac, I think Mr. Bell recommended iTerm 2 or something like that. But Putty is kind of my go-to way of connecting to a Unix server via text. So just Google Putty, and I use DuckDuckGo, of course, because it's it respects your freedom. So yay. So if you just search for Putty, go to download stable and download the 64-bit installer for x86, which is what probably most of you guys have. Run that, it'll install Putty, and then when you launch Putty, you will get a window like same Putty setup as last time. Yeah, let's disconnect here. You'll get a window like this, and the website is, or the IP address for the server is csci4x.com. csci4x.com. We'll post that in here on Discord. So that is default port 22, that's SSH port. So when you connect to the server, it will ask you for your username and password. So it doesn't for me, by the way. It logs me in automatically, and I can show you guys how to set that up if you want. You're on a Mac, use the built-in terminal. Yeah, if you're on a Mac, you can open up the terminal and you can connect to the server like this. SSH wkearney, that's my username. Your username is going to be your last name, like Leong _ your student ID 123456 at csci4x.com, and replace this with whatever your student ID is. And if you have terminal on Mac, you can connect that way. It's your username at csci4x.com, and that when you do that, it'll ask you for your password. Your password by default is your username. But notice that when you type in a password, no password appears. This is something that I get questions about every semester. It just doesn't echo the characters for security reasons, okay? So you have to type in your password blindly, and once you type it in, the first time you log in, it will go through a password change process. You have to type in your current password again, you have to type in the new password, and then your new password, and then it logs you out, and then you have to log back in using your username and your new password. So there's a little bit of a annoyance. You guys are third semester computer science people. I'm not too worried about it. First semester people, it's usually a bit of a train wreck getting people who have never programmed before to type in a username and password. So iTerm 2 can save profiles. Yeah, I think iTerm 2 supports 24-bit colors, or is it the other way around? Do you remember, Mr. Bell? Like if you're on the server, and you run like public S80 public Kyoto, does it give you does it give you a 24-bit color, or does it like explode? iTerm 2 works with the colors library. Yeah. So I seem to think that the built-in terminal doesn't. I don't know. I'm not sure. You think you typed your new password wrong? Good. So you changed your password and then forgot your password? Do you use the built-in terminal for Windows? No. For Windows, use Putty. My recommendation. You could. What was the command for that picture? Once you're logged in, Asadi is my image viewer for terminal that I wrote, and I've got a couple images, test images that I use. That's a shot from the Gion district in Kyoto. If you want to render it in full resolution, you can actually change the font size of your window to 1. That makes every font 1 pixel high, and when you run it, it actually will render every pixel in the image in full resolution. You can see it's not especially fast, right? So this is why we use image viewers instead of terminals for things, but it's still pretty good. This is Putty rendering a high resolution image at 24-bit color, so it's pretty cool. Michinoku. Kane knows. Why not WSL, by the way? I mean, you can. If you want to try it out, let's give it a shot. I don't know if it supports. I don't know if the Windows thing supports 24-bit color. So Mac default terminal doesn't like colors. Yeah, that's the downside. So Nguyen, do you need me to reset your password for you? So everybody, please get all logged in here. Only a few of you guys are. So let me put the information back over here on how to log in. So if you're on Windows, download Putty, run Putty, connect to the server. and your user is your username and password are both your last name underscore your student ID. And then when you log in, you go through a password change process. When it finishes, it boots you off. Then you log back in with your new password. And if you forget it immediately, just message me and I will reset your password to something. Betancourt, you are kind of confused. Do you have Putty installed, Betancourt? When you open Putty, you get this. Yes. And so you type in the host name. So here, you're going to type in as the host name csci4x.com. That is our class server. Okay. Then hit OK. And when you do that, it will log you. It'll ask you for your username and password. And remember, the password does not echo to the screen. All right, so we need to reset Garcia's password. All right. Garcia, can you message me your student ID? Here is the tutor schedule. So, Nick DeFuria, interesting. Valenzuela, he's taken all of the computer science classes. So, yeah, I'll go through these things and let you guys know when there's going to be experienced tutors available. Ada, can you bring me the phone, please, girl? All right, and we are back. So, you should be looking at a screen that looks something like this. We are going to go over the basics of Unix really, really fast. You're all third semester computer science people, so you should be able to learn Unix quickly. If you haven't, if it's still confusing to you, come to my office hours and I will walk you through Unix a little bit slower. The Surrey Unix tutorial is really good. I recommend this to all my students. If you've never done Unix before, do the first 2 to 3 chapters, somewhere in there. I would actually go through the whole thing. The more Unix you know, the better off you will be in your computer science career. It's just a given. Knowing Unix is actually really good for your career. Research shows that having Unix as a known skill is worth a $5,000 a year pay differential. People that only know Windows make less money. It's actually really important to know both Windows and Unix, honestly, and maybe Mac in theory. So let me post this URL for you, and it will give you a gentle introduction to using the Unix system. But I'm going to give a very high level, very brief overview of all the commands you need to know. First command is called ls. For you guys, it will show absolutely nothing. For me, it will show a lot of stuff. ls shows you all of the commands in your current directory. So I will type up the notes here on Discord. ls show all files and folders in the current directory. Second command is cd. Again, you don't have a directory yet, so this isn't going to mean very much. But cd changes directories. That's what cd stands for. So if I want to change into the Pokedex directory, I can type Pokedex. I can type it out the whole way. The faster way is to hit tab, and it will do what's called command line completion, and it will fill in as much of the name as possible. In this case, I have 3 directories that start with poke, and so it fills in as far as it can and then prints the options. So I want to cd into Pokedex, and then I can type ls again, and it'll show me. I can open up 001, which is Bulbasaur. There you go. Vim 68, and was it matchamp or something like that? Okay. So if you type cd with no parameters at all, it takes you back to your home directory. Your home directory is represented by a tilde, also known as the cheat console character. If you play video games, it's the top left corner of your keyboard is the tilde key. It represents your home directory. Okay. So you notice the prompt shows you which directory you're in. Here I was in the Pokédex directory. Now I am back in my home directory. Okay. The next command we're going to write is, do I have a, I already have one, huh? Move main.cc to triangle raster.cc. This is what we're working on IS50B, rasterizing triangles. We have a little software rendering engine we built in IS50B last semester. It's kind of fun, all right, so let's start like this. Type vim linear algebra. Oh yeah, it's definitely linear algebra in it. So vim like main.cc is going to edit a file called main.cc using the vim text editor. You do that, it opens up a blank page. Now, when you're in Vim, there's only 3 things you need to know at the beginning. Inside of Vim, you need 3 commands to get going. If you type I, it puts you into insert mode. Watch. See down here, insert mode. Escape puts you back into command mode. And then Shift-ZZ saves and quits. So the 3 commands you need to know is I to go into insert mode, escape to go back into command mode, and Shift-ZZ to save and quit. That will get you going on Vim. So Vim is an interesting thing. So Vim is very different from most text editors. If you've never done anything in Vim before, it's weird. You can't just like type. If I hit keys, the keys don't appear on the screen. I have to hit I to go into insert mode, and then once I do that, then I can type in hashtag include IOStream using namespace standard int main cout hello world. And then once I'm done typing, I hit escape, and you'll see that down here, insert mode turns off. I'm now in command mode. So what the hell is command mode? Well, Vim is amazing because you can actually issue commands to your text editor. What the hell does that mean? All right, well, I can say YY, and that copied a line to the clipboard. And I can hit P to paste, and I've just copied and pasted something. All right, well, you can do that in Windows. You can like select the thing and hit copy and hit paste. All right, cool. But can your Windows do this? YY 1000p. So I just pasted, 10,000p. So I just pasted that line 10,000 times. Okay. And I can hit U and undo all 10,000 of them at once. I can edit all 10,000 lines at the same time if I want. There is a amazing and rich set of commands you can do in Vim. All you need to know to get started is I puts you into insert mode, escape puts you back into command mode, and Shift-ZZ saves and quits. Okay. All right. 4th command you need to know is G++. If you're new, I would actually use the compile script. So compile main.cc. That it's a shell script that I've written for you guys that does various pre-checks and static analysis and things like that. It compiles your code for you. So the 4th command you need is compile main.cc. And then the 5th command and final command you need to know, and that's it. I'm throwing a bunch at you all at once, but I'm going to post this on to Discord so you have a handy dandy reference is a.out. If you do that, it will run your program. So my program, if you recall, was this, and when you run it, you get hello world twice. So how did I go back up through the history? I hit up arrow, up arrow, up arrow, up arrow. You can press up arrow and down arrow to scroll through your command history, and you can run a command again by just hitting up arrow, return. So if I were to make a new version of this where I wanted to print hello world 10 times, print I equals 0, I is less than 10, I plus plus, Shift CZ to save and quit, G++ main.cc, or I could use compile main.cc, either way. G++ is kind of a what compile calls, but compile does static analysis. So if you're new, use compile, I guess. It'll do that whole thing. And then a.out to run it, and there you go. Got hello world 10 times. Yep. And there is the cheat sheet for Unix on Discord. So the commands are ls to show files and folders, cd to change directories, vim to edit a file, and G++ or compile to compile the file, a.out to run the file. And you're going to do steps 3, 4, and 5 over and over again. Okay. So, you're going to have to review this. Yeah. Okay. Well, it's pinned on Discord. Those are the 5 commands you need to do over and over again. If you fall into an infinite loop, like a student just said, they just posted an infinite loop, that's an infinite loop. It will run forever. So if it's going to run forever, hit Control C. Control C cancels an infinite program. There's 20 hello worlds. Okay. When will you be able to use these commands? When you're on the Putty. Yeah. Oh, you mean like ls and cd? You can do them right now if you want. They won't do, like after you create a file. Like you'll see main.cc wherever it is. There it is. Yeah. So once you've created a file, when you type ls, you'll see main.cc. Once you've compiled it, you'll see that there's a program called a.out. A.out is the default name for an executable if you don't provide one. So, Betancourt include IO stream, using namespace standard, void message, string message, cout message. All right, that's good. Were you able to compile it and run it? Betancourt? Yep, okay. Moya, there's a question I meant to ask you. You said last semester you measured in physics because it was easier to transfer. Can you expound on that? My counselor has me working towards CSCI, but I'm shooting for the UCs too. Let's be honest, I am still learning more Unix and Vim magic. Yeah, it never stops. What did I learn the other day? I learned something cool the other day. Can't remember now. But yeah, like there are so many different tricks and hacks and things like that with Unix and Vim that you just never stop learning. But the more you know, the faster you can code. How do I do code block? Code block? And on Discord, triple backtick. So on Discord, you're going to type something like this: C++, cout. If you do that on Discord, then it will format it. Yeah, it'll format it with oops, double tick. No, maybe you need that on its own line. Yeah, the C++ has to be on its own line, so you need to hit return right there. So, and then it will format the code with C++ formatting. I did get a triple associates, including physics. Oh yeah, that's something that all of you should look into. Which is that a lot of times when you get an associate's degree in like computer science, you're actually probably only like one class away or two classes away from associates in physics or something like that. So keep an eye on your, I don't know, or maybe just talk to a counselor or something. Just see, hey, what associates do I qualify for? I don't know if it's going to make a huge difference in Muya's life that he has 3 associate's degrees, but it's kind of cool. You can, after he gets his doctorate, he can be like, Nick Muya, PhD, comma, MS, comma, BS, comma, AS, comma, AS, comma, AS. You just have this super big academic credential right there. Okay. So, and also a lot of students don't know that we have associate's degrees, which is kind of weird, but because a lot of people just come here and then they transfer to another college. And they don't really think about the associates, but why not? Just get some letters put after your name. And I guess we'll talk more about that 4th semester. But yeah, just go into counseling if you have to. I think you can find the major sheet somewhere, like what it requires to take to get an AS in computer science. And probably after this semester, most of you will qualify. So I'll remind you all about it later. Okay, so let's talk about C++. How does that sound? Do a little review of C++. We'll do that for a little bit, and then the last hour, 3-hour classes. Okay, so major requirements. There we go. You need CSCI40 and 41, which you should all have, and then from the list A, you must have 26 this class. 5A, 5B, 2A, or 4. Yeah, you guys could probably actually get a associate's, maybe either right now or after this semester. Because most of you will have taken 5A and 5B, right? And physics as well. It's required, I think, to transfer. So just apply for it. You can get one in math, yeah. It's like once... There's so much overlap between the different associate's degree, you might as well just apply for all of them. And yeah, it just makes you look cool. I don't know. Might help you get a job. It's possible. I don't know. In general, like computer science jobs, a lot of them are just experience based, but whatever. Like more letters after your name isn't gonna hurt you. Yoxlamer, can you look up the requirements for a Japanese major, foreign language major? I'm actually curious to see if I qualify for an Associate of Arts in Japanese. That would be hilarious. I'm one of the few people that chose not to do physics. Couldn't justify the online physics experience. Yeah, Karne-chan. Yeah, yeah. I took Japanese 1 with Nico in fall of 2019, I think, and then JT, who's the president or something like that of the ACM, was taking Japanese 2 last semester in the spring, and he's like, "Yeah, you got to take it with me." I'm like, "All right, dude, I'll take it with you. It's online. I can do it without having to get a babysitter for my kid and stuff like that." And then he dropped, so I ended up just taking it anyway. And Dr. Nicholas Muya, Mr. Doctor Professor. If you get the reference to it. All right. Yeah. So I took Japanese 2 and did all right in it. Couldn't take physics online. Yeah, it's rough. Okay, so let's go over C++. All right. Let's start off with the basics. Do you guys remember variables and x equals 0? Do you remember how to output stuff? Thing 1, make a variable and initialize it. You guys all remember how to do this? I hope you guys remember how to do this. Good. Much discipline needed for online STEM classes. Alcohol EDU training. That's funny. You guys all remember how to make a variable? How do you make a folder? If you want to make a folder, it's makedir. Makedir blah. And then you can cd into blah so you can experiment with it, I guess. That'll make you happy. How about header files? Yeah, you can do header files. Yeah, but we're going to take it one step at a time. So step 2 is... Please enter an integer. Output. Scan into x. Input. See out. Your number is. And this is also output. Okay, so if we were to run this, please enter an integer, 42, your number is 42, cool. If any of you guys don't remember one of these things, because I'm going to just kind of assume you guys all remember this. League of Legends had a bug last week where it's like, your teammate object. Alright, so... let's do if statements. So if x is equal to 420, this is going to be conditionals, I guess they're called. Conditionals. See out. Access granted. You are in the mainframe. There you go. Else, see out. Access denied. So conditionals have if, else, yeah. It's a program. You guys know that. And the 1 means exit failure. Same thing as 1. Okay, so conditionals. So if I run this, please enter an integer, 420. Congratulations, you're in the mainframe. Any other number, it'll print out access denied and quit. Okay. Hack the mainframe. That's right. Isn't there a library to get color text? Sure, if you want. And if you want to use my, I have a couple header files that I use with my classes that make life a little bit easier. So instead of these 3 things here, by the way, this is how you can comment out lots of things. These are comments, block comments, and comment out large chunks of code. So rather than these 4 lines of, rather than these 3 lines of code, we can just do this, int x equals read. Please enter an integer. That. And this does 1, 2, 3. Makes a variable and initializes it with the number read from the keyboard. So if you've never had me for a class before, you will have never seen this function before because it is something I have made. But I like it because that's 3 lines of code. That's 1 line of code. And if you type in something that's not an integer, it won't accept it. Whereas before, if you did this, it would break, right? And you have to handle the breaking. So if we type in 420, access granted. If we type in some other number, access denied. Okay. Give them begin at the first assignment. Okay, so, and then if you want to do colors, color text, do something like this. See out green. Again, see out green. And see out red. And again, there you go. You do green text. Access denied. Okay. So 420, 69, yeah. The meme numbers. Purple is not a color, yeah. If you want to do purple, you could do something like 24-bit color is allowed. Set color 2550-255, and you can get purple. So this again, it's part of my colors library, which is just a very simple way that you can change the colors of text and things like that. There have been various discussions on the C++ Standards Committee about, or not the committee, but the discussion forum about this kind of stuff, and it's an interesting world we live in. I've actually been paying a lot of attention to like the standardization process and how all that works, and there's a good talk that I've been watching on what belongs in the standard library, and it's kind of a mess right now, to be honest. It's kind of a mess. Like, they're not actually adding anything that I would consider to be useful, at least for you guys, for students. They're basically doing things that make people to make header files' lives easier. Very little to make the lives of new students better. Although the ranges library might, we'll see how it pans out. Modules might, we'll see how it pans out. Okay, so yeah, these libraries are things that I've made. You can find them on GitHub. I'll post the link if you want them on your own computers. But they do make life easier. Okay, so conditionals, then we got functions. Bool password check takes an int. This is 5 functions. So this is a function that returns a Boolean. It's named password check. It takes one parameter. Let's not call it X. Let's call it pass or something. And if you want to figure out what's going on here, it's going to compare pass with 420. If it is 420, then it is true, and it returns true. If it's not 420, it returns false. You don't technically need the parentheses there. So this function returns true if they type in the password, which is 420 correctly, and if they don't, it returns false. And so down here, we are calling password check, passing in the number they entered. If it returns true, we print out access granted. If we don't, we see access denied. And we can do, let's see, 60, 30, 10. Get brown. So 32-bit color. Kind of cool. Let's make it a little brighter, I guess. 60, 40, 20. It's a little brighter. Yeah. 24-bit color. Cool stuff. All right. Type HTOP. Yeah, so HTOP is the task manager, or it's not the task manager, but it's like the task manager on Windows. Shows you all the different cores. This is a dual core system. We're working on getting a better server set up for y'all. It's got 4 gigs of RAM, It's been up for 7 days. I rebooted it right before the start of the semester to get some security updates in. You can see all the different people who are running stuff and whatever. It doesn't really matter. Okay, the return value is true because I'm comparing the two values. Yeah, so if I pass in 500, it's going to compare 500 with 420. 500 is not 420, so the equality operator returns a Boolean, and so then it returns that Boolean. A lot of students, by the way, would write this code like this: if pass is equal to 420, return true, else return false. This is far too verbose. In fact, don't write code like this. If you ever find yourself saying if something is true, return true. Otherwise, if something's false, return false. You can usually just cut out the middleman and just do that. Okay. Not the else. It's just like you're saying. Basically, what you're writing is this, right? Like if true, return true. You know, it's unnecessary. Okay. So yeah. So just this is fine. This explodes students' brains sometimes, but it's good for you. It's good for you. It's better than the if else. It does the same thing, but without the conditional. And conditionals are actually pretty expensive, right? So the cost of an int comparison will be somewhere between 1 and 8 cycles, depending on the cost, and it's just unnecessary. That said, the optimizer would probably remove it, but it's less writing and it's faster. So yeah, this is the better way of doing it. Yeah, like there's some applications where like if you even just structure a single if statement wrong, and wrong meaning it's correct, but you just didn't. Like it's correct, but the compiler, like for whatever reason, can't predict its value or something. It can actually slow down your program by like 50%. Like if you're in a really tight loop and you mess with your if statement in a certain way, even though it's still correct, it can actually slow down your program significantly. So in a situation like this where a function runs once, it makes absolutely no difference. Nobody's ever going to see the difference between what I had before and what I have here, but why type more? Type less, right? Less is more. Okay. Okay. So that's a function, and then let's talk about containers, which is kind of what I wanted to get to here. And then at noon we will take one more break. So let's talk about containers. Containers are classes that hold lots of data, aka a data structure, I guess. There's probably some technical difference, but it doesn't matter. So a container contains data. It's, yeah. So if you've taken data structures, you learned about linked lists and hash tables and stuff like that. Yeah, like I said, there's probably some difference there. I don't know. I can't really think of anything off the top of my head. More or less the same. So, container number one, contestant number one. Container number one is the vector class. They are the vanilla ice cream of data structures. Vanilla ice cream, by the way, is not bad. It's just not special. Okay. Most ice cream dishes use vanilla ice cream in them, right? Vanilla goes with everything. And so, generally speaking, when I need to hold a lot of data, I will use a vector until I decide I don't need one. Right? So, let's say that I've got a... let's say that I've got a file that has a ton of numbers in it. Okay? And I just want to, I don't know, read in these numbers. I don't have bash. Well, I'm not in bash, I should say. There we go, random numbers. All right, cool. There. I could have written a shell script to do that, but it seemed more fun to whack on the keys. Okay, yeah, don't use arrays. Yeah. Don't use C-style arrays, especially. Don't use C-style arrays ever. So that would be something like int r100. No, don't do that. Okay. You could probably find some sort of case where they're better, but even in those cases, you want to use a C++ array class. There's an array class in C++ that's just better. So in general, though, we use vectors instead. C arrays are what wiped out the dinosaurs. Yeah. Don't use an array of characters either. Use the string class, right? Okay, so vectors. How do you do a vector? So let's read in all these numbers. So there's the IF stream ends, opening up random numbers. Thank you, autocompletion. You're a hero. Okay, so I'm going to say while ends. Yeah, let's just do while. Yeah, while ends is fine. Int x, I'll shadow it, whatever. I'm going to read from the file a number. You could use int x ends into x. If you guys remember how to read from files this way, that'll read a number from the file into this variable x. I just use my read library. It's nicer. Sorry. So it's going to read a number and goes into x. And if there's anything in there that's not an integer, like I type squirrel or something accidentally, just silently discards it. It's nice. It's a lot more fault tolerant than CN. What's an example of a data structure that ends in a container? I don't know. Okay, so read a variable from the file, and then we're going to make a vector. All right, so we're going to make a vector of integers called vec. And what we're going to do is we are going to call it vector dot push back x, and this will add. So this here will read an integer from the file, and this will add the integer to the vector. And then when we're done, do not. It's hard to talk and type at the same time. Then when we're done, we will print all the elements in the vector. And this is something that some of you might not know, and that's the range-based for loop. So you can say for every integer x in vector, this syntax here was added in C++ 11. So some of you might not know it. Depends on your professor. But that says for each. It's a for each loop. For each, or it's a range-based for loop is another way of putting it. For each integer x in vec, what are we going to do with that x? We're going to print it to the screen. So for every element x in vector, print it to the screen. And that's a nice, concise way of doing a for loop damn. Enter the password. Okay, there we go. And you might notice that we got an extra 0 at the end. Okay, and the reason for that is because when you read from the file and there's nothing left, it throws an error. So what you have to do is say if an error was thrown, then break. And if we do that, then when we run it, you'll see the 0 at the end does not appear. Okay. So if an error occurs, it'll return 0, and but you need to check to make sure you didn't run off the edge of the file. Okay. This will stop it anyway, but you need to check prior to stuffing it into the vector. Oh. Are we staying till 12:50 today? Yep. That's technically the schedule. So I need to update my my faculty card. Okay, so you're in a new scope, you're redeclaring x again. Thought that would cause problems. Nope, it's called shadowing. So int x here is shadowing the x in the other scope. the other x is not accessible now that we have our own x. Okay. So because we have an x here, I could actually do this, right? I could see out x, right? And then that would print out 420, right? And then after that, it would print the value read from the keyboard. So you can see 420, 420, 420, 420, 420. So at this point in time, x is referring to that x, and now that one is referring to that x because it's shadowed. So you can only have one copy of a variable per scope. So if I were to try to make another int x, like if I copy paste that and I have two int x's, can't do that. But if you have an enclosed scope like this, you can actually make another x. Is that good practice? Probably not. This would confuse the hell out of people, right? Like, why is this always 420? And this is the value from the file. What the hell is going on? I don't recommend it. I'm just doing this to demonstrate the concept to you guys. Okay. And so this is a range-based for loop. So this says for every element in the vector, print it. Yeah, so you can nest scopes. Yeah, you can have anonymous scopes if you want. Like you can actually do that if you want. And x, yeah, you can do that. Notice there's no compiler error there. That is valid C++. I don't know why you do it, but you do it. All right. Yeah, if you have a shadowed variable, you're always accessing the one in your scope here. Right? So that's referring to this x. Okay. Okay. So that is a vector, easy peasy. We can even combine this, maybe. Whatever. So we read a value, make sure that we're not off the edge of the file, and then add it to the vector. Okay. So there are other containers as well. Container number 2, and I'll just stop here. Unordered map, aka a hash table. So if we make an unordered map, you connect. Actually, it's already noon. Let's just do this. Okay, we'll connect string and int, and we'll call this calendar. While true, string s equals read. Please enter a month in your new calendar. So what we're going to do is we're going to make a brand new calendar, like the French Revolution, right? They made a new calendar that was more even, the months having even numbers of days. Please enter a month in your new calendar, and we're going to have int days equal to read. How many days does this month have? If you ever heard of the Thermidorian reaction, it's because it was in the month of Thermidor. They made their own calendar because they were call this string month days. And then if you want to add it to the unordered map, you can simply say calendar square bracket month equals days, like that. Or you can say, you can call the actual insert function as well. But what this will do is if they type in January and 100 days in January, then this hash table will say, all right, January has 100 days. And then when we're done, we can say for every auto x in calendar. So for every entry in our hash table, it's going to give you two things. It's going to give you the name, and it's going to give you the number of days they have. if month x dot first is the month, has x dot second days. And so this is saying for every entry in the hash table, print the name of the month and how many days it has. Please enter month. January has 100 days. February has 28 days. March has negative 30 days. April has 3.1415 days. Okay. I don't have any way of getting out of this, do I? I don't. Okay. If month is equal to done, break. We need a way of escaping that, don't we? Okay. So enter an integer 420. All right. Enter month. January has 100 days. February has 28 days. March has negative 100 days. April has 690 days. Done. Oh, shoot. Done. There we go. And then you'll see that it prints out the whole hash table. But, yeah. Okay. So, January, February, March, April. Notice how they're in no particular order. That's why it's called an unordered map. There's no order in it. Okay? So it is held in no particular order. So that read speed is so good for loading data. Yeah, it makes writing your code a lot nicer. And you don't have to handle errors every time and stuff like that. It just really does speed up your coding time. Okay, so unordered map is your hash table. Basically, you associate a value and a key, or a key with a value. And so the keys in this case would be like February, and the value that it has is 28. January is the key, 100 is the value. April is the key, 690 is the value. So you're associating a value with a certain key, and you can change them. If I said hash table square bracket January equals 1,000, then it changes to 1,000. The only real risk of this method with using the square brackets is that if you try printing something, like if I try printing calendar square bracket December, if this doesn't exist, it creates an entry for it. And that's bad. That's actually really bad. You don't want to just, you don't want, it's really weird. You don't want C-outing something to create an entry in a data structure. Titus Winters, who's head of Google's C++ efforts, basically said that he has a game he plays with his team trying to figure out what's the most useful part of C++ that doesn't have a sharp edge to it. And this would be a sharp edge of the unordered map class. If you see out something that doesn't exist, it inserts it into the table. So you can use contains, and there are functions. You want to see if the thing exists before you see it out. We run it. January has 31 days. March has 31 days. February has 28 days. Done. You'll see that December has been entered into the hash table with 0 days. So for unordered map, your keys and values can be of any type. You can associate anything with anything else. If you've ever used JavaScript or Lua or things like that, this would be called an associative array, where you can associate, in this case, we are associating a string and an integer, right? So we use a string to look up a value, and that lookup takes place in order one time. It is very, very quick. It's very fast to write data and read data, and delete data. But it's not ordered anymore, so it doesn't preserve the order that you put things into it. So here we have the sharp edge, right, where it will insert 0 into the hash table for you. But basically every entry in the hash table is two things. It's a string and a integer associated with it. And so when you do a range-based for loop with the hash table, it gives you two things. It gives you a pair, technically. And the pair has a dot first and a dot second. The dot first is the string. The dot second is the integer associated with it. And you can associate anything with anything. Yeah. Okay, so let's go ahead and take a 10-minute break, and then when we come back, we will talk about modulus. Let's start doing mathy stuff. Cool. Okay, here we go. So, that was a brief overview of C++ and the vector and unordered map data structures. So, yeah, those are probably the two most important ones. Hash tables have order 1 performance for find, insert, search, and remove are all order 1. So super fast. Vectors are used when I want to keep the data in order. You know, push 1, 2, 3, 4, 5. When I print it, I get 1, 2, 3, 4, 5. With an unordered map, it's like whatever order. That's why it's called unordered. You lose the ordering, but it's fast. So any sort of like database application you can think of, or like you're trying to keep track of all the phone numbers of people in Fresno or something like that, where you got like 500,000 entries, and you want to look up somebody by their name or whatever. Hash table is really fast. You can look up their name, order 1, there's a phone number. Whereas when you search for it through a vector, you have to go through every element of the vector. Now, if the vector is sorted, then you can do it in order login time. But then you have to sort the vector every time you add or delete to it. It can take time as well. All right, so we got Kratos using a computer for some reason. Interesting. Okay. The container part of the lecture. Okay, you're lost on the thing. Was there attendance today, Mr. Singh? You have to take the daily quiz. There will be a daily quiz on something that we talked about in class today. Maybe 2 questions, maybe more. Who knows? And that will check to see if you were paying attention, and that counts as your attendance. Okay. All right. So let's change that to CSCI41. There you go. Okay, so discrete math. Why is it called discrete math? By the way, this is discrete, not like secret. It's not discrete. It's not discrete math like that, right? It's discrete like that. 2 totally different words. Discrete math means the numbers are not continuous. So, integers, right? So math is a different endeavor when you are working with integers rather than continuous variables. Like, we're used to working with floats, right? When you plot something on the Cartesian coordinate system, you draw a straight line, right? Every value off to infinity, can be represented by y is equal to mx plus b, right? You have some slope, you got some y-intercept, and it's infinite length, and it has an infinite number of points between, 0 and 1 even, all right? So that's kind of how we're used to doing with numbers in math, and we're not going to do that. In discrete math, we are working with integers, okay? We are working with integers. And so what that means is the kinds of problems that are easy and hard change, right? If you do floating point division, you can't ever have a remainder, right? Because you'll always just get some decimal number of times it divides in, so you can't have a remainder really when you're doing floating point division, right? So you can only do remainder stuff with ints, really. So that's nice. But a lot of problems get a lot harder when you have integers instead of floats. So with integers, you can have even and odd numbers. That concept doesn't exactly make sense. Now, math people have defined what it means for a floating point number to be even or odd. I've read papers on that, and it's all fairly silly stuff to me. Like, is 3.1 even or odd? Is 4.1 even or odd? I don't know. Take your pick. I don't know. It's not a question that interests me particularly. But for integers, you can have even or odd numbers, and At some point, we're going to talk about combinatorics. Combinatorics are the different numbers of ways you can combine things together. How many different ways can 3 people stand in line at the DMV? There's 6. We can prove that. We'll learn that in our second major unit on combinatorics. How many different passwords are possible if you allow 5 character passwords? How many different possible passwords are there? It's combinatorics. That's discrete math. We're used to working with ints in computer science, and so it seems like ints are easier to work with than floats, right? Well, depends. Ints have a nice property that they don't change, right? With a float, if you add 3, if you multiply a number by 3 and divide a number by 3, you're probably not gonna maybe get the same number back out. It depends. Does the optimizer recognize it and delete the operation? You might get the same number, you might not. Floats have inherent error in them like that, whereas integers don't. Right? Integers can overflow or underflow, but they don't have error in them. So that's why we like using integers when we program, right? Because there's no error. It'll run the same way every time. If you have a for loop that says for int I equals 0, I is less than a million I plus plus, it'll run a million times. With floats, it might be a million times. It might not be. Okay. So the trouble is, though, it actually makes a lot of problems harder. So, for example, there's a knapsack problem that is very famous in discrete math, and this will be the first thing that we talk about this semester. So imagine that you are robbing a store, or you got a shopping spree paid for by some TV show. It doesn't really matter. It's Black Friday, broke into Best Buy. I don't know. So you walk into the store. You got a backpack that carries 10 kilograms, which is like what, 22 pounds in freedom units, something like that. So you've got a backpack that holds 10 kilograms. So there's stuff in the store, and let's say there's 4 things in the store. There's gold, there's silver, there's lead, and there's applesauce. And you can walk out of the store with 10 kilograms of stuff, and you're trying to maximize your value. Okay? Gold is $36,000 per kilogram. Silver dust is $490 per kilogram. Lead is $2 a kilogram. And applesauce is 17 cents per kilogram. I have not updated these prices for the 2021 inflation. So, whatever. These are 2018 numbers, I think, something like that. So risk it all for the applesauce. See, I would take the gold and I'd mix it in with the applesauce and get like some Goldschlager, level applesauce. But like, let's say you're trying to optimize for money. What is the optimal route here? What do you fill your backpack with if you are trying to take as much money out of the store as possible? What do you guys think? 10 kilograms of gold dust. Pretty easy. Right? Fill it up. Okay. It's worth the most per unit, so we're done. Okay. And, all right, let's make it a little more interesting. Let's reduce how much gold is available. So there's only 1 kilogram of gold. There's 2 kilograms of silver dust. There's 3 kilograms of lead. And there is still 100 kilograms of applesauce because the people ahead of you in line at Black Friday already took all the expensive stuff, right? So what now? Take a moment, look at it, and then post onto Discord. What is the optimal haul, right? If you're trying to fill up a 10 kilogram backpack with these options, you can take at most 1 kilogram of gold, 2 kilograms of silver, and you can mix them together, right? You can take, for example, a kilogram of gold and a kilogram of lead and mix them together. You would probably annoy the hell out of the assayer that had to appraise your thing. You'd probably have to sift it afterwards or something. I don't know. I'm not really sure how it works. So Singh says a kilogram of gold, 2 kilograms of silver, 3 kilograms of lead, and 4 kilograms of applesauce. Man, you're going to have some toxic applesauce when you're done with that. Let me tell you. You got lead in your applesauce? My lord. It's disgusting. So, Mmm. See, gold in the applesauce, that sounds kind of interesting. Lead, though? No thanks. Right. Yeah, you're exactly right. And so what you do in this knapsack problem is you just go down the line, right? Like I'll take all the most expensive stuff, then I'll take the next most expensive stuff, then I'll take the next most. And this is a very boring problem. It's a boring problem because it is continuous. Okay? When you have continuous quantities, you just pour in as much of the most expensive stuff first and continue down the line. Okay? So, the person I sell the applesauce to can worry about that. Yeah, it's very expensive applesauce at that point. It's toxic and expensive at the same time. So, I know some people like that. So, it gets harder though when you have integers. Okay, so with integers, the thing becomes a little bit trickier, right? So I've broken down the price of these different things per kilogram, and so the most valuable option there is the Dyson sphere, I guess. And then there's other options, but you can't just like go down the line and take the most expensive stuff, as it turns out, because you actually will not get the optimal result if you do that. If you just say I'm going to take the most expensive thing available, and then take the next most expensive per kilogram thing available, you can actually get stuck and not have the most valuable combination. So it gets a little bit more tricky. And by a little bit, I mean a lot more tricky. So again, you've got 10 kilograms in communism units of loot available to you. You got a 4K TV that will take up the entire backpack. I'm not sure how you'd stuff a 10 kilogram. I don't know. It's a math problem, okay? It doesn't have to make sense. So you can stuff one 4K television into your backpack worth $1,200. You can take a 1080p television worth $920. You take 720p televisions worth $333. You can take 480p TVs worth $180 each. And you can take a Dyson sphere. It's a very small Dyson sphere, obviously. It's not a full-sized one. A full-sized Dyson sphere will obviously encompass the entire solar system, so this is a little bit smaller than a full-size Dyson sphere. Do you guys know what a Dyson sphere is? It's also a vacuum, I think. No, an actual Dyson sphere is a proposed megastructure where you wrap the sun in basically solar panels, if you want to think of it that way. And so it's envisioned that like a high technology alien civilization would trap all of the energy out of the sun and make use of 100% of the sun's energy for their needs, you know. And so various astronomers have looked in the skies trying to find the radiological signature of what you would expect if a star was completely enclosed in a structure. Kind of cool. So it's an overpriced vacuum also, yes. So, if you go with the most expensive first, you would take the Dyson sphere, and then you can't take the 4K, but then you would take the 1080p, right? And then you got £1 left, and that space is wasted, and so you'd end up with 1320. However, you can do better than that. You can do 3 720p TVs for about $1,000. Plus 400 for that. 1 plus 9 is 10 kilograms, so you'd end up with $1,400 instead of $1,320. So the upshot here is that all of a sudden it becomes a tricky problem. You can't just go down the line taking the most expensive stuff. You actually need an algorithm to do it. And the algorithm to solve the knapsack problem is actually a very beautiful one. And we might, I don't know, it could be a fun programming assignment for you guys to do. They thought they found a ring structure, but it wasn't in the end. Yeah. So, do you guys understand? You don't have to solve this right now, like the general problem. Not this case is pretty easy. But do you understand how, like, when you make things integers, all of a sudden, like, it gets harder, right? Do you guys? That's kind of the point here, right? When you had continuous quantities like applesauce, you just right pour the applesauce in, pour the gold in, you know, it's an easy problem. It's a very easy problem. It's a trivial problem to solve. With integers, though, imagine you've got 1,000 things in Best Buy you can take. You know, if you go through every combination of item, you're talking about an exponential search, right? You're 2 to the 1,000th power. You'll never be able to solve it. You need to have a clever algorithm to solve the integer knapsack problem. Okay. Do you guys understand why the integer problem is harder than the continuous problem? Okay. So, yeah, I don't know why there's no applesauce available in this one. The applesauce was gone at that point. Get into Best Buy and Black Friday. Where's the applesauce? I actually just got a TV from Best Buy and returned it a couple weeks ago. Looked good on paper. The specs were all really good. But specs lied. Why return? Well, I will tell you why. So, I have been looking for a new monitor. The monitor I have is actually a really nice monitor, but it makes noise. It is a really nice monitor, but it makes noise. And I've been recently moving towards a all-silent computer system. And so, like, when my computer's on, you can't hear it. It is passively cooled. When I run a video game, it does make noise, but I have a pretty decent heatsink on my video card, and so it's like, you know, it's not bad. It's not bad. And so I was looking at replacing my noisy Asus monitor. There's a fan on the G-Sync card apparently, and it just constantly goes. So I was looking at this guy, and ticked all the boxes. 43 inches. I was actually looking for as small as possible, because it needs to fit on my desk here. It's actually a computer monitor, right, that I'm using it for, not a TV. And so with TVs, like, bigger is like more expensive, right? If you go up here, it's $2,500. If you go the smallest, it's $750. It's a cheap price, right? And I would actually want smaller. I actually think the ideal size for a computer monitor for me is probably 34 inches. That's kind of what I've determined I like on a computer monitor. I have a 27-inch here, a little bit too small. So I've got a 34-inch now here. But anyway, so 43 inches was big. Like, it ate up a lot of real estate on my desk, but it was doable. And the reason why I got it was because I looked at the specs. And I love how they've been using the same art for breathtaking colors. They've been using these for 30 years. It's like in Italy somewhere. I'm sure you can find the same image being used. This is how beautiful our monitor is. Here we go. Specifications. So, it has HDMI 2.1. Why does that matter? Well, DisplayPort 1.4 can't do 144 hertz 4K. It's not a bandwidth. So I've been looking for a HDMI 2.1 monitor that can do 4K 144 hertz, and also a high refresh rate monitor as well. My Asus here is 4K 144 hertz, but it can't do it because it doesn't have HDMI 2.1 on it. It can only do 98 hertz because it's a DisplayPort 1.4 port. So I've been looking to upgrade, and it's noisy, which, as I said, I don't like. So it ticked all the boxes I was looking for. It had a high refresh rate. It had variable refresh rate, which is the generic name for G-Sync. So that was nice. There we go, variable refresh rate. That said, it has a little note on it, and that note is not implemented yet. So they have, in theory, variable refresh rate on it. It doesn't work, though. So it does not actually do it currently. They say it will come at some point. And then native 120 hertz panel, so not 144, but 120 is not bad. And it says it does video signal support. Interesting. It says it only supports it at 60 hertz here. That's interesting. Elsewhere it says it supports 4K at 120 hertz, right? And it doesn't. That's the kicker, right? It works fine at 60 hertz. It does not work at 120 hertz, even at 2K resolution. It will display an image on the screen, but the image adds random pixels here and deletes random pixels here, so it adds noise to the image screen. So it looks garbage. Like in a video game, I guess it's okay, even though it kind of looks garbage. Adding noise to the pixels kind of evens out over the time. But if you're using it as a monitor, if you draw a straight line, it goes like this. Horrible. Absolutely horrible. And so basically it's only usable as a 60 hertz monitor, which defeats the entire point of having HDMI 2.1. So, yeah, so I returned it. Long story short. So that was my Best Buy TV experience. So I ended up getting a Aorus from Newegg, and that one was garbage. It was the VA panel, and VA panels apparently are garbage. I don't know. I haven't bought a VA panel in a long time. I'm an IPS fanatic myself. So I returned that one, and then I got another Aorus, which is a super speed IPS panel, and that's the one I'm using right here. It looks quite nice. The only downside to that one is the max brightness is not very high. It's got a max brightness of 400 nits, which is not good enough for me. My Asus is 1,000 nits. It looks quite nice in HDR. Okay, so what do you think of the LG 49BL95C 49-inch curved HDR IPS monitor? Okay, well, take a look at that. I'm not really a big fan of curved monitors, so I probably wouldn't have even looked at it. Was this a dual QHD? Yeah. You can certainly do coding on that. If you're doing Java coding, you need if you want to display the whole line in Java, you need a monitor like that. But it's not enough resolution for me. I like 4K, so like I said, I'm kind of a snob. I like 4K IPS screens, at least for now. Yeah. So the Aorus FE43U. This was the one I looked at first, and here we go. And it won the Tom's Hardware Best Panel Award, King of the 43-inch class from Tom's Hardware. If you go through the reviews, though, you will see how many people were shipped with dead pixels. Mine had a dozen dead pixels on it. That, in and of itself, was just... No. I'm not going to have a black region of screen the size of a grain of rice on my screen at all times. I am sorry. That is not good. And the kicker is I had to pay a $150 restock fee because I'd opened the box. I opened it and was like, no. And then I returned it. And also, the colors on it were just not good. It just was not a good quality panel. And it ticked all the specs, 144 hertz refresh rate, HDMI 2.1, has a really good color gamut, 10-bit color. Nope, it's no good. Absolute garbage. So I returned that and got I don't remember which one I got. It doesn't matter. Okay. I got a super speed IPS panel, and it's quite nice. Okay. So, modulus. The Newegg return policy is garbage. Yeah, $150 restock fee, which is, they sent me a damaged monitor. Right. So, but you opened it. Yeah, you have to open it to know if it's damaged. Like, come on. And I'm sure I could have protested, and they probably would have sent me another one. But at that point, I didn't want it because the colors weren't any good. So, whatever. Yeah, Costco. Yeah, or Best Buy was actually quite reasonable to return stuff to as They just plug it in and make sure the thing still works. All right, here we go. No restock fee. It's all good. All right, so modulus. We're going to be talking about modulus for about 2 weeks or so. So just to test you all on your modulus knowledge, what is 10 modulus 3? Let's see if you guys can remember how the percentage sign works in C++. What is 10 modulus 3? We have 8 people still here at the end of class. Cool. Sakana, thank you. Thank you, Sakana, for participating. Yeah, 10 modulus 3 is, in fact, 1, because that is the remainder. 3 divides into 10 3 times with a remainder of 1. So it is the remainder operator. And we use this to do things like, the obvious things are like, does x divide evenly into y? Right? That's the obvious thing we used the modulus operator for. Another obvious thing is even and odd, right? Does it, you divide by 2, or you modulus by 2, and see if there is a number left over. If there's a 1 left over, it's odd. If there's a 0 left over, it's even. Some maybe less obvious things would be like getting the last digit of a number. Like if I give you the number 1, 2, 3, 4, how do you get the last digit? If I give you 1, 2, 3, 4, I give you a variable that has some number in it. How do you get the last digit out? How do you get the 4 out of it? So if I give you 1, 2, 3, 4, how do you use modulus to get the 4? Yep, modulus by 10. So if you divide 1, 2, 3, 4 by 10, you get, it divides in 123 times with a remainder of 4. And then if you wanted to get the 3 out next, you can divide 1, 2, 3, 4 by 10. It becomes 123. And then you modulus it by 10 again. You get 3. If you want to get the next number, divide by 10. It becomes 12. Modulus it by 10. You get 2. Divide by 10. You get 1. Modulus it by 10. 1. You get 1. Divide by 10. 0. You're done. And so if you want to get individual digits out of a number, and here, let me just show you how to do this on here. So we're going to read an integer. All right, so while x this might not work with negative numbers. We'll make you an unsigned integer just for the hell of it. Okay, so while x is not 0, do you guys know you can do this? This is equivalent to saying while x is not equal to 0. So while x, see, the last digit is x modulus 10. And then you can say x is equal to x divided by 10. Or if you want to be super fancy, x divided by equals 10, which is valid C++. So this says x is equal to x divided by 10. And it will spit out the digits from back to front. So if I type in 423, and let's go 420, why not? The last digit is 0, the last digit is 2, the last digit is 4. Okay. You guys see that? So if you don't pull one digit out at a time, you can do something like that. What do you guys think? Kind of cool? Destroyed our number, of course. So we'll always fail the password check now. So yeah, we can pull one digit out of a time, out of a number. If you want them in order, you can like push them into a stack and pop them off the stack or whatever. But, you know, you get one digit. And that's useful if you're doing like a game like Mastermind, where like you've got a secret password, 5528, and the user guesses 4520, and you're like, all right, 2 of the digits match and 2 of them don't. You would use a trick like that. It's a nice use of modulus. But we're not really going to be doing much of that, at least right now. Instead, we're going to be talking more mathy stuff. So, some terminology. Z. Have you guys ever seen Z to represent integers before? Z. So Z is the set of all integers. Okay. And a lot of times it's written with like a little slash through it or something like that. Just so you know that it means all integers. It's special. Math people love symbols and love special meanings to special characters, and they'll use a phi and a with a zigzag line on it, and I don't know. It seems almost deliberately designed to make the thing look impossible to understand. But basically, a lot of math comes down to just understanding what the symbols and terminology mean, and once you understand it, it's a lot easier to understand. Right? Taking calculus, yeah. You have all these like curly Q's and things like that. So, with Z, you can actually add a little subscript to them. So, for example, if you have Z subscript 10, this is the subset of Z containing the numbers 0 to 9. It is the first 10 integers after and including 0, if you want to think of it that way. So if we're dealing with Z10, then the only integers that exist are 0 to 9. Okay? There's 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You guys understand? So if we do Z5, the only numbers that exist are 0 to 4. Because there's 5 numbers that exist. 5 integers that exist. Z5. Okay. Quiz question. Sure. Okay, sure. Why not? How many integers are in Z9? Okay. So, there are rules for doing math in modular worlds like this. Okay. And the rule is if you're in Z10, and like let's say you're at 9 and you add 1, like 9 plus 1, you get 10. Normally, you'd get 10. But there's no 10. There's no such thing as 10. What you do is you modulus the result. So 9 plus 1 is 10. 10 modulus by 10. Every time you do an operation in Z10, you always take the result and modulus it by 10. Okay. So if you add 7 plus 8, you get 15. 15, you then modulus by 10. What is 15 modulus 10? 5. Yep. Very good, very good. So 7 plus 8 equals 5. You guys understand? So in the world of Z10, 7 plus 8 equals 5. And this is the point at which my wife comes in and goes, 8 plus 4 equals 2. I'm not really following where the modulus comes in. Every time you do math in Z10, every time you add, subtract, multiply, or divide, whatever result you get, you modulus it by that number right there. You modulus it by 10. Okay? Because the only numbers that exist are 0 to 9. There are no other numbers in the entire universe of Z10. So if we say, for example, what is 3 times 4 in Z10? How do you compute 3 times 4 in Z10? Good. Yoxheimer, do you see what we're doing here? 3 times 4 is what? What is 3 times 4, Yoxheimer? 12. And then, because we're in Z10, we modulus by 10. Okay. So inside of Z10, 3 times 4 is 2. Okay. What about 0 minus 1? So if we have a number line, you know, we got 0, 1, 2, 3, 5, 6, 7, 8, 9. So if we go 1 to the right and we get 0, what happens if we go 1 to the left? What number do we get? So what is 0 minus 1 in Z10? What do you guys think? If you're at 0 and you go 1 to the left, what do you get? If the number you got was a 3-digit number, you'd still only mod by 10. Yeah, because there's only 10 numbers. You just keep going around and around and around. If you take 9 times 9 and times 10 in Z10, that's 81 times 10 is 810. 810 modulus 10 is 0, right? So yeah, 0 minus 1 is 9. Okay. So if you go 1 to the left, you get 9. If you're at 9, you go 1 to the right, you get 0. It wraps around. It's a circular. There's like this really deep philosophical connection between modulus and circles, right? You keep going bigger and bigger and bigger, then you wrap around to the smallest, you get bigger and bigger and bigger, you wrap around to the smallest. It's like a clock, right? It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Or if you go the other way, 12, 11, 1, 12, 11, 2, 3, 2, 1, 12. Do you guys understand? So it's like, you can kind of almost think of it as a circle. Okay. The same 10 numbers are recycled over and over again. Yeah. So, yeah, and so that's Z10. Z10's pretty easy to do in your head, right? What is 7 times 6 in Z10? What is 7 times 6 in Z10? There's that. It's like how hashing works. Exactly, yeah. Hashing is one of the classic examples of modular arithmetic. You go to the end of the hash table, you wrap around back to the beginning. Circular arrays, same thing. You go to the end, you wrap around to the beginning. You go off to the left, you wrap around to the right. Yeah, circles and modulus kind of are conceptually almost the same thing. Yeah, so 7 times 6 is 42. 42 modulus 10 is 2. So 7 times 6 is 2. Okay. And there's something called a congruence class. So even though the number 42 doesn't exist, we say it is congruent to 2. This is essentially the same number. 7 times 6 is 42. 42 is congruent to 2. So math people don't like using equals. It hurts their brain. It hurts their brain to say 42 is equal to 2. Right? So instead they put a third line on there, and they say it's congruent. It's essentially the same number. But we refuse to acknowledge the fact that they're equal, because 42 and 2 aren't equal. So they're congruent. They're the same number, essentially, in a modular world. See you, Betancourt. Yeah, so math people will throw a third equal sign on there, and it just basically means they're the same number. Okay, so we refuse to acknowledge the fact they're the same number, but they're okay, so if you have negative 7 times 6 equals negative 42, when you modulus it by Z7, you would be 8, yes. Negative 2 is 8, right? So if you're here, if you go 1 to the left, it's 9. If you go 2 to the left, it's 8. Okay. So, addition, subtraction. What is, okay. All right, give you guys a harder one. What is 5 minus 10 in Z10? What is 5 minus 10 in Z10? You guys are all saying 5. No, 5 minus 10. 5 minus 10. No, it's 5. I'm just messing with you. And we know that because if you go 10 to the left, you end up where you started, because there's 10 numbers, right? So if you go 10 to the left, you end up where you were. If you add 10, if you subtract 10, same number. What about if I said, what is 7 plus 100 in Z10? What is 7 plus 100 in Z10? Yeah, it's also 7. So every time you go 10 to the right, you end up back at 7, right? So you go 10 to the right, 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 10 to the right. It's 7. All right, let's make it a little harder. Let's make it a little harder. Okay. 2 plus 101 in Z10. This 2 plus 101 in Z10. Kicking up the difficulty here. Yeah, it's 3. Yeah, because if you want to think about it this way, you can just take 101 and modulus that by 10. 101 is congruent. 101 is congruent to 1. And so whenever you're working with modular arithmetic, you can always just switch out any number for any other number it's congruent with, because they're the same number. So 101 is the same thing as 1. And so you can just rewrite this whole thing to just be 2 plus 1. What do you guys think? Deceptively easy or incredibly mind-blowing and tricky? What do you think? Suspiciously easy? It's got to be a catch, right? All right. Let's give you a real problem. All right. 1 million billion trillion and 7 plus 1 million billion trillion. Those are all zeros, by the way. Plus 1 million billion trillion. I don't know if that's a 9. I'll make it a 9. I think it was supposed to be a 4. So it's 1 million billion trillion and 7 plus 1 million billion trillion and 9 in Z10, obviously. So 1 million billion trillion and 7 is congruent to 7. 1 million billion trillion and 9 is congruent to 9. 7 plus 9 is 16. 16 is congruent to 6. You just modulus by 10. And so the answer is 6. Okay. Couldn't add for a second there. Yeah, that's right. It was originally going to be a 4. So. Yeah, and so on my old midterms, I'd give these modular arithmetic problems that were literally like 500 digits long, right? Modulus 10. Right? So you just look at the last digit. Right? I would just sit there and hit the keys on the keyboard. And it would be so long that even if you had a calculator, you couldn't enter it into the calculator because the calculator would explode, right? So, yeah, anytime you deal with Z10, you just look at the last digit. You know what I mean? And add them or subtract them or whatever. And that's what you're going to have to do on your quiz today. So I'll just give you some very simple modular arithmetic problems, and you can test out your knowledge for yourself and do addition and subtraction and multiplication and not division. Because division's a little bit weird. Division is strange. Modular division is really strange. So that's it for today. So thank you for coming to class. Thank you for signing up for another semester with me. I appreciate you all being here. If anyone needs to add, please message me. I will give you an add code. And I add everybody. It's my policy. I just add everyone up to the fire marshal limit, essentially. And I will see you guys on Thursday. All right. Thanks a lot.